All right, what's up, Math 8? Today we are doing 8.3, which is the volume of spheres. Um, so we'll just go ahead and jump into it. This is our last volume, or I guess our last figure that we're going to do volume over. So yeah, we'll just jump into it. So this is on page 606. Okay, the formula for the volume of a sphere is going to be V equals 4/3 times pi r squared. All right, so here that is just rewritten in my own handwriting. Or sorry, not pi r squared, pi r to the third power. Okay, be careful on that one. Obviously, I just said it, and it's very easy to get that mixed up. So be careful on that. Try not to make that same mistake that I just made. All right. So if we go ahead and look down at example 1, we have this sphere where we have 6 millimeters for the radius. So I'm going to go ahead and plug that into our formula. So we have V equals 4/3. So 4/3 times pi r to the third power. Okay, and then I'm just going to go ahead and plug in. All right, so the radius here is 6. Okay, and then from here, we can just rewrite it and then find 6 to the third power. I don't know that off the top of my head. I know it's 36 times 6, which will give us 216. Okay. All right, now we can go ahead and just multiply all these together in our calculator. All right, for 4/3, what I'm going to do is I'm just going to do in my calculator 4 divided by 3 to start. And I'm going to do times pi, or 3.14 for our purposes. I'm just going to type it in like that. So that's going to give us, if I just do that, I'm going to type it in as I talk. So I get 4 divided by 3. That's 1.3 repeating. And then times 3.14 times 216. And that's going to give me 904.32. All right. If we check what they've got 904.8, but they probably put in the calculator pi instead of 3.14. Okay, so just as usual, we want to show our units, and remember that's going to be units cubed because it is a 3D figure, and that's it. That's how we solve for the volume of a sphere. All right, so I want you to go ahead and use those same steps that we just did, and I want you to try out Got It Problem A on your own, and also Got It Problem B, just to make sure we get good practice with it. Once you're done, we will go ahead, we'll pause the video and work on those, but then once you're finished with those, we'll continue on with the lesson. All right, so let's go ahead and look at example 2 here. It's just a real-world example of how we would use a sphere. Okay, so it says a spherical stone in the courtyard of the National Museum of Costa Rica has a diameter of about 8 feet. Find the volume of the spherical stone, round to the nearest tenth. Okay, so once again, I'm going to plug in, or I'm going to start with my formula. So we have V equals 4/3 times pi r to the third. Okay, and then I'm going to go ahead and plug in what I already know. So they don't tell us anything about the volume, but they do tell us that the diameter is about 8 feet. Remember, whenever we have the diameter, we're going to take that and divide it by 2, and that'll give us our radius. For this one, that's going to be 4. So I'm going to go ahead and plug in 4/3 times pi times 4 to the third power. Okay, then from here I can just simplify again, right? So we have 4/3 times pi. 4 to the third power should give us 64. All right, and then I can just plug this all into the calculator again. Okay. Quick note, make sure, again, I know we talked about this in previous videos and previous lessons, make sure this step where we find that exponent, make sure you do that first before you do anything else, okay? So I know I just hadn't said that yet, but there it is for you. So yeah, we're going to go ahead and put that in our calculator. So 4 divided by 3 gives us 1 and 1.3 repeating again, times 3.14. And then times 64, and that gives us 200. Whoa, that's highlighter still. Sorry. That'll give us 267 point. If we round that, that's 9.5 for our volume. That's pretty close to what they got. And then we got to have our units. So they're telling us here that the diameter was about 8 feet. So our units are going to be feet. So yeah, we have feet, and then again, 3D measurement, so it's going to be feet cubed. And that's it for the volume of the sphere given. All right, so I want you to try to interpret, this is page 607, interpret, got it, problem C, and solve it on your own as well. So once you've done that, you can go ahead and resume the video, and we'll keep going with the lesson. All right, so number 3 is pretty similar to number 2, except there's just one more step. And I think it's really, really good for us to see it just because, well, number 1, it's a really good real-world example where we see the, it's going to talk about the, like the inflation of a volleyball. For me personally, I know when I was playing soccer in college, we had to inflate our practice balls to it had to be at a certain pounds per square inch or PSI level. So a certain weight that you inflate it to. And the same thing, I would assume, maybe goes with volleyball at that level. So this is kind of cool to just kind of see where that those measurements come from. This is exactly how they would do it. So yeah, we're going to look at it. I also think it's really important because it shows us how to find, well, we'll just see. All right. So, yeah. Number 3, it says a volleyball has a diameter of 10 inches. A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball round to the nearest tenth? Okay, so right away we can see that this is a really good real-world example. If you have ever been inflating a ball for sports or something, or if you ever inflate a tire, this is kind of something that comes up and you're like, okay, how long should I air this up? Because I don't want to not inflate it enough, but I also want to make sure I don't overinflate it and make it pop. All right, because no one wants to pop a tire on the road, right? So we're going to go and start again just with our formula. So we have 4 over 3 times pi times the radius cubed. All right, and then we're going to plug in the information that they give us. Okay, so it tells us the diameter is 10 inches. Okay, right away, I'm thinking diameter, I need to divide it by 2, so that's going to give us 5. All right. So yeah, I'm going to plug in V equals 4 over 3. And my radius is 5. Okay, and then it also says a pump can inflate the ball at a rate of 325 cubic inches per minute. All right, that's going to actually come in later. So for now, I'm going to go ahead and I am just going to solve what we have here. Okay, so for this one, we have V equals 4 over 3 times pi times 5 to the third, which is 125. All right, I'm going to plug that all into my calculator. So I get 3.14 times, 4 divided by 3 first, times 3.14. and then times 125. I'm going to get V equals 523.33. All right, it was 3 repeating, but that's fine for right now. Obviously, they get something a little bit different here, right? But again, they just used pi instead of 3.14. All right, sorry guys. I had a meeting I had to go to real quick, so I kind of lost track of where I was. I do have here that we got that our volume is 523.33, and that's inches cubed. Okay. And then it says that it takes, whoops. Okay, it says that it takes the pump a rate of 325 cubic inches per minute. I know earlier I said we weren't going to use it yet, but we are at the point of using it. So basically what we want to do with that is we know that we have 325 feet cubed. Is that right? Inches cubed, sorry. In 1 minute. Okay. So what we can do is just take this volume down here. Okay. And then we want to divide it by, it's going to be X minutes, right? Because we're trying to find X here now. Okay. So then I have this ratio, and really all I need to do is go ahead and multiply both sides by X. Okay, this 1 down here, we can just ignore, right? Because anything over 1 is itself. Okay, so if we multiply both sides by X, that's going to get rid of the X's here. And we have 325X equals 523.33. Okay, now we can divide both sides by X. Sorry, not by X. Divide both sides by 325. All right, and then from that we should be able to get our answer. And then when I do that, I get 523.33 divided by 325. I type that in my calculator. I'm going to get X is about 1.6. Okay, and that's going to be in minutes, right? So it's going to take about 1.6 minutes to inflate the volleyball. Okay, if we wanted to change that to minutes and seconds, that would be 1 minute. And I believe that is 6/10, which is 3/5. 3/5 of 60 would be, well, 6/10 of 60 would be 36 seconds. Okay. So if you wanted to see the minutes and seconds, that's what it would be. All right. I know I said earlier in the video that this was going to be a pretty good problem as far as just like knowing how to do it. And it was pretty important. This is actually not the problem that I was thinking it was when we first started out. It's not a huge deal if you got a little bit confused, specifically once we got to the purple stuff. That stuff is a little bit more confusing. It doesn't really go with what we are doing here. So if you didn't get that stuff below, not a big deal, but please do make sure you know how to do all of this with finding the volume of the sphere. Okay. All right, so this next problem and our final problem is for a hemisphere. Okay, a hemisphere is basically the same thing as a half sphere. Okay, so if you want to write that down, that's not what they put in their own definition, but that's the easiest and most simple way to define that, is just it's going to be like half of a sphere. All right, so if we look at a hemisphere's volume, okay, because it's half, right? We did this on our scavenger hunts already, where we just take the normal formula. So we have 4/3 pi r to the third, and we're just going to divide by 2 or multiply by 1/2 okay, because it's only half of the figure. All right, so I'm going to go ahead and do 1/2 times this, okay, and then I'm going to plug in, so this is our formula. If we look at example 1, it shows that we have a radius of 5, so I'm going to go ahead and plug in 5. So V equals 1/2, forgot the 4/3 there, times 4/3 times pi times 5 to the 3rd. All right, and then that'll give us 1/2 times 4/3 pi times 125. And then I'm going to go ahead and plug in everything except for this 1/2. What I'm going to do is I'm going to actually go ahead and divide by 2. All right, so I'm going to do all the stuff in parentheses first, put it in the calculator. So I'll have 4 divided by 3, hit enter. And that number I'm going to multiply by 3.14 times 125, hit enter, and I get 523.33, and then divided by 2, and that will give us 261.67, and that is centimeters cubed. All right, and that will be the volume of a hemisphere or a half sphere. All right. Okay, so this is a longer video, and I recognize that. I do want you to go ahead and do Got It Problem E for me real quick. And then after we do Got It Problem E, that is going to be it for this video. So sorry it was a little bit longer, but make sure you get that done. It's good practice. After that, we will be done for the video, and I will see you guys in class.